The triangle PQR, so PQR, is right angled at R. And X and Y, so X and Y, are the midpoints of QR and PR respectively. So X is the midpoint of QR and Y is the midpoint of PR. Prove that 5pq squared is equal to 4px squared plus 4qy squared. So from the diagram by Pythagoras' theorem, we have pq squared is equal to 2a squared plus 2b squared. So we know that Pythagoras' theorem states that c squared is equal to a squared plus b squared, where c squared is the hypotenuse. So pq is the hypotenuse. So c squared is equal to a plus a, which is 2a squared, plus b, which is 2b squared. So c squared is equal to a squared plus b squared. C squared is pq, so we have pq squared. We can label QR, we can rewrite it as 2a because this distance we're going to call a, this distance we're going to call a, and a plus a is 2a. And we know that these two are equal because x is the midpoint. And you don't have to go with a's, you can go with whatever letter you want. And likewise over here, y is the midpoint of PR, so this distance is equal to this distance. So b plus b is 2b. So pq squared is equal to 2a squared plus 2b squared. 2 squared is 4, a squared is a squared. 2 squared is 4, b squared is b squared. So we get pq squared is equal to 4a squared plus 4b squared. We're going to divide across by 4. Pq squared divided by 4 is going to be a quarter pq squared. 4a squared divided by 4 is just going to be a squared. And 4b squared divided by 4 is going to be b squared. So we get a squared plus b squared equals a quarter pq squared. Also, ax squared is equal to a squared plus 2b squared. So px is going to be the hypotenuse of the triangle PXR. So we have px squared is equal to a squared plus 2b squared. So we've only got a single a now at the bottom, but we still have the 2b at the side. So again, by Pythagoras' theorem, px squared is equal to a squared plus 2b squared. And 2b squared is 4b squared. So px squared is equal to a squared plus 4b squared. And likewise, qy squared is equal to 2a squared plus b squared. So if we take the triangle QYR, the hypotenuse is QY, one of the sides is b, and the other side is going to be 2a, so a plus a is 2a. So qy squared is equal to b squared plus 2a squared. So qy squared is equal to 2a squared plus b squared. 2a squared is 4a squared. So qy squared is equal to 4a squared plus b squared. So if we add them, px squared, we're going to rewrite as a squared plus 4b squared. So we got that from over here. And qy squared, we're going to rewrite as 4a squared plus b squared. So we got that from down here. And adding them, we get a squared plus 4a squared is 5a squared. And 4b squared plus b squared is 5b squared. And factorizing, we get 5 times a squared plus b squared. So px squared plus qy squared is actually equal to 5ab squared plus b squared. Now we worked out a squared plus b squared to be a quarter pq squared. So we're going to swap this a squared plus b squared for a quarter pq squared. And obviously we bring down the 5 and the brackets, very important, don't forget the brackets. So we have px squared plus qy squared is equal to 5 times a quarter pq squared. And we're going to multiply across by 4. So px squared times 4 is 4px squared. Qy squared times 4 is 4qy squared. And the quarter and the 4 will cancel out. So we're left with 5pq squared. So we have 4px squared plus 4qy squared is equal to 5pq squared. And that is what we were asked to prove. So you could have labelled your triangle as anything you wanted. You didn't have to go for A's and B's. You could have gone for H's and T's, or P's and Q's. Maybe not P and Q actually, because you're already using P and Q in your triangle. But you don't have to go for A and B. You can use whatever you want. It'll still work out the same.